Hello, my name is Dina.
And my name is Bjørn, and we would like to show you our shader project, which is about toon shading.
Toon shading is also referred to as cell shading, but in this video we will only refer to it as toon shading because of the assignment description we have for this project. Instead of the art, we will refer to 3 different games which use this toon shading method in it. The first one is from the Bodyland series. The Walking Dead series.
And I know you're a killer. The world has ended out there. Who cares who I am?
These people are could be dangerous.
And the not yet released Dragon Ball Xenoverse game.
歴史が変わっていく。A sudden crisis grips the universe. 自分なりなりあなたの伝え聞いている歴史とは結末が変わってしまっているはずです。
The model used for our shader project was originally published by David 3D. The model was imported from Unity's asset store and came with its own toon shader. For that reason, we only imported the model itself and the texture that followed with it, as well as all the necessary components to make the figure work without any flaws or errors in Unity. Here we see the model imported into Unity with its texture assigned to it. From here we browsed in Wikibooks for code references and found a template code for toon shading which we used for our project. However, the shader code only used a basic color for model texturing and required some rework to implement the original texture of the model while still maintaining the cartoonish attribute. Through many trials and errors, a feasible result was finally achieved, which you can see in front of you. And now we're going to have a look at our toon shader project. To begin with, we define the name for our shader, which is toon shader. Afterwards, in properties, we define the different variables which can be edited in Unity, such as our unlit outline thickness, which defines the thickness of the model outline, and also main text, which takes in the texture map. It's very important that it is called main text, as it's sort of the standard name for any texture applied to a model. In Subshader, we start coding how the shader behaves in Unity. Pass and tags structures the code in defining the effect of each light source, which is placed in Unity. It is important to note that we are stating a forward base as it is the first light we are coding. CG program tells the compiler that we're using CGP coding language, and here we state that we're using vertex and fragment shaders. With this code we access the Unity CG Inc library for additional functions, and afterwards we define the color of the light source. Right around here we define some user specified properties. You have to take note that of the data types for the different variables, as some, like unlit color, takes in the RGB and alpha values of a color, whereas main text, which is our texture, it requires sampler 2D, which is the standard data type for texture. Next, we define 2 structs. one which takes in the visual data, working with the vertices of the assigned object. So to say, this struct works with the vertex shaders. And also do pay attention to your text chord numeration, as you have to, each time you have a text chord, you have to give it a new number accordingly. In this struct, we work primarily with the fragment shaders. In terms, this is where we use the properties. In here, we define the vertex shader for our assigned model, which is the warrior. Here, we assign a value for our variable model matrix, which more or less define the values of the world space. And following is the variable where we assign the values of the model in world space. In here, we store the position values of our model object in world space. Afterwards, we multiply the normal vector of the struct vertex input with the matrix model matrix inverse and assign the value to output normal dir once it is normalized. Reason why we normalize is because the length of a given vector is not important, and the calculations used requires less processing power when finding an angle between two normalized vectors. In here, we multiply three predefined matrices, the MVP, with input.vertex, and assign it to the variable output.pose, which basically means that we project the model onto the screen. And here, we assign the output text chord with input text chord, and in the end return the output, which is pixel fragment color values.
And here we begin our fragment shader. In this fragment shader, we check what sort of light that are used on our model, and also additional behaviors are added to the model, which give it this cartoonish look with these highlights. Okay, so to start off, we normalize the normal dir once again, which we also did up here, because we just want to be on the safe side that it is normalized. So we normalize it once again. Down here, we normalize the distance between the camera and our object, and we also declare two new variables. And here we have our if statement, one of our if statement. This if statement decides if we have directional light or not. If it is 0, 0 we have here, from up here, then we have directional light. But if it's not equal to 0.0, then we will have either point light or spotlight. In our if statement, we normalize our light world space position so that we give our light a direction. But as you can see, we only give it a direction. We don't subtract it with for example, the input world, the input position world, which is the object, our model. So because with directional light, that is not important. But we do that here in our cone, our spotlight, or point light, since we need to have the direction between the length between our light and our model. And now we go through the else statement. Here we create, in first line, we create a direction between the light source and the model. Then we use the predefined length, which is here. Then we use the predefined length to calculate the length of the vertex to light source, which we call the distance, the result of that. Then we divide the linear attenuation 1.0 with the distance. And lastly, we normalize the vertex to light source, meaning that we normalize the position vector to give it a direction. Here we are making a new variable which we are calling for fragment color. We're giving it the type of float 3. Normally you will give it the type of float 4 because you normally include the transparency. But right now we don't need to import it right now, which is why we first we will do it down here instead. Okay, and now we have 3 different if statements. It is very important that these if statements are in this order. You can think of it a little like if you have a piece of bread with butter on it and avocado on it, then you want to have the bottom with the bread, and then you want to have the butter, and then on top you want to have the avocado. So yeah, you can see this has low priority, and then this have a higher priority, and then this have the highest priority. This is the first if statement out of 3 who are giving our model this cartoonish look. This if statement is the lowest prioritized out of the three of them. In this, we multiply the attenuation with the highest value between 0 and the dot product of 2 variables, which in this case is the normal vector of our object in space and the vector direction of our light source in space, and check if it is higher or equal to the diffuse threshold. When taking the dot product of 2 vectors, we multiply the vectors with each other, which gives the scalar product of the angle between the 2 vectors. The diffuse threshold which we use is set to either diffuse color or black, and the higher threshold we have, the more black we will get. And then we calculate one part of what defines our Toon shader and assign it to fragment color, as shown here. And in the 2 other if statements, we also assign a part of what defines our Toon shader, just on top of what already have been added. Here in the second if statement, then we create a smooth transition between the darkness and the light. So if the angle between the camera view and the normal vector is less than the angle between the normal vector and the light direction, then we will get the outline in this. Now we go to the last if statement, which is also the highest prioritized if statement of the 3 of them. Here we say if the light shines upon the fragment of the assigned object and attenuation multiplied with the angle between the view direction to the power of the variable shininess is more than the value of 0.5, then we will provide this highlight effect. Then here we are making our fragment color into a float 4 instead of having it as a float 3 as we had here earlier. And by doing that, then we are giving it the transparency, which we are here set it to 1.0, so that there is no transparency. And that is actually the end of the pass. And here we have the second pass in our code. This pass are dealing with additional light source and more intense light on the model. But since most of the code are just the same code as what is mentioned above in this first pass, then we're not going to go through this. The only difference in it is that it is is here down here, where it is working with shininess. In short, you can say that it is working with black and white instead of working with colors. That's what happens in this pass. And that's it. Thank you for your time.
We hope you enjoyed it.